Service Monitor Manual 2008, publishing the modern take on the ancient art of monitoring production services. As Paul said, my name is Nicholas Ivano. I work as a production engineer in Facebook Dublin office. So a little bit more about myself. I'm production engineer at Facebook. Production engineering is Facebook's take on SRE with our own twist. This talk is not going to be about what production engineering is, but there's a fair few of us at the conference. So if you're interested in this, in the role, just grab one of us in the hallway and we'll be happy to talk to you about this. Previously, I worked as a software engineer in a bunch of industries. I worked on all sorts of things. I worked on embedded systems, cloud infrastructure. I worked for a telco company. So I wrote a lot of code, pushed it to production, and it was rarely monitored properly. So I'm going to give you a little bit of an overview of what to expect in the next 20 minutes. I'm going to talk about modern practices on monitoring production code. So what I hope to give you is like non-exhaustive, ad hoc yet cohesive take on monitoring. And I hope you will leave here with hopefully some fresh ideas. Some of these things will seem familiar. Maybe make you think about monitoring and make sure that you think of monitoring as a first-class thing if you aren't already. What I will not talk about is history of monitoring, because it's a subject in its own and it's really not for a 20-minute talk. What I will also not talk about is specific tools, even though they are important and the open source world has seen in the last 5 or so years a lot of excellent solutions becoming mature and getting monitoring to where it needs to be, even though it's not as ubiquitous as it needs to be throughout the industry, I think. Okay, so a little bit in terminology, logging, monitoring, or observability. This is kind of like the new word du jour. I'm going to excuse myself if there's French people in the audience. So what I'm talking about here is like logs metrics that you turn into charts and alarms. You query in real time and aggregate and potentially process offline. You can think of this as observability. I think observability is kind of like a term companies in the space used to differentiate themselves, and I don't work for such companies, so I don't find it as appealing. But if you want to substitute observability for when I say monitoring, that's fine. I think modern systems should be doing all of this anyway, so we may as well call it monitoring. Okay, so the talk is going to have 4 parts, and I gave them quirky names to keep you guys engaged. So, first part, the question. Chapter 2, the knowledge. Chapter 3, the trial. And final chapter, the legend. Okay. So, chapter 1, the question, or rather, asking the right questions. So I borrowed this bit from the seminal Google SRE book. Basically, we want to be asking 2 questions. What's going wrong? So am I breaking my SLA? Am I breaking my promise to my customers? So this is usually high-level stuff like, am I serving requests? Is there a lot of latency? And then you want to ask, if something is going wrong, why it's going wrong. So that's basically all the other stuff you've collected from your systems to be able to dig into stuff and figure out why you're not delivering on the promise to your customers. So while we're on the topic of questions, and this is generally good life advice, is know your audience. What I mean here is different people. When you think about monitoring the data you're getting out of your systems, different people will have different needs. So it's good to be cognizant of that. People coding will have want to look at different things than people, debugging the system or running it in production. And then maybe, other teams at your company will want to see different stuff around user engagement or something like that. So it's good to think about who is looking at the monitoring data. So I'm a firm believer in people who run code in production understanding what it does. And I don't only mean, like what your application does, but how it actually does this and how the whole thing hangs together. So a good example is your application containers or like your service frameworks will have their own queues and threading and all that sorts of stuff. And you probably want to know how it works so that you can monitor it properly and get the right conclusions out of your metrics. Another important thing is knowing how your service fails. What happens if your downstream dependency is down? What happens if there's a spike in latency in the system? Okay, and a bit about debugging, and the reason I put firefighters in the debugging slide is not because I think debugging should be firefighting. It's actually quite the opposite. This is from a book called Thinking Fast and Slow. It's by a world-renowned psychiatrist, psychologist, I think the latter, who goes into how human brain works. And he talks about a thing called expert intuition, where experts build on the body of knowledge they have to hardwire basically the fast path in their brain to be able to make expert decisions, but fast. And this is kind of like where you want to be with your monitoring and your tools around monitoring services. You want to make your production engineers, SREs, people running the system, be able to develop an intuition about how the system behaves based on data. The reason firefighters are in the slide is because firefighters are an example of experts who can like walk into a dangerous situation and make fast decisions based on intuition. So going forward, chapter 2, the knowledge. This is a photo of Trinity College Library in Dublin. So if you're ever in Dublin, that's where we're based. It's a very nice place to visit. So this is going to be about collecting the data. This is how I think about this. So you have your host level data. So this is basically stuff about your machines in your fleets. You probably do not want to use this to alarm because you want to think about your users and not your infrastructure, but this can be useful when digging into problems. Then service level, this is what your app is doing. We'll focus on this later. This is something I've basically split out because I think it's very important. That comes from mesh, from the service mesh. It's kind of like a new thing that people talk about, but this is basically your networking layer, how your services communicate. Usually part of this will be, your service discovery, your load balancing, your back off. If you get data and good data from this layer of your app, it can be very powerful. It can give you powerful insights in what's happening in your whole system. And then you have like higher level aggregated stuff, which can be useful if you aggregate on failure domain. It can give you like a quick insight into what's happening if there's something wrong at the higher level. When it comes to actually how this works on a high level, I think of it as I call it the agent model. Basically, the idea behind this is that the software that's responsible for collecting metrics should be deployed and developed separately from applications because usually it has wildly different concerns, reliability guarantees, and so forth. So it's I think, a very mature model to think about how you are going to get the data out of your services. So then there's the networking library, which I think is very important, so I separated it out. And yeah, so these arrows are here to kind of like signify that agent is getting data out, but it can be a push model as well. And then it gets sent off to your collection pipelines, which are also a topic that I will not cover here and are a huge topic in themselves. So yeah. So now when it comes to your services, you basically want to think about the data you're getting out in terms of counters and in terms of logs. Counters are fairly obvious. You count things. They can be any sorts of numeric values, so number of requests, latency in seconds, milliseconds, and that kind of stuff. Usually you want to aggregate them and calculate stuff like percentiles or averages, depending on like what you believe the distribution of data is. Then you want to send it off to Timeseries DB. Timeseries DB is basically a place where you store time-stamped numbers, and you can query them across namespaces or across time ranges. There's a number of open source solutions I'm sure you're all aware of, like Graphite or lately Prometheus. At Facebook has recently, a few years ago, I think, open sourced our backend for storing time series for our system called ODS. And the trade-off it's making is a very interesting one, and why I'm bringing it up here is it focuses on answering queries quickly. And the reason it does this is because if you have real-time querying, then your engineers start using this as a tool for debugging and getting insights into data. So basically what it does is it keeps everything in memory and aggressively compresses it. There's actually even a paper out on how it works, and it's open source, so I encourage you to look into it. And then we have logs, but the point is for them to be structured logs. I think, like, your old school logs are a relic of a simpler time when we didn't have this level of people working on services that are distributed across thousands of machines. So nowadays, really, if you're logging something, it's fine to use, your old printf to debug, but probably if you're sending logs from your production systems, you want them to be structured. So what I mean about structured, this is completely contrived example from made-believe service. Basically, it's schema-ish data. You want to send stuff about like the code path you're in, how long it's taking, maybe which request you're responding, which version you're running, and that kind of stuff. So basically stuff that you would log normally, you do the same thing but with structure. So this looks cool, but when it becomes really powerful is if you can aggregate it and query it in real time. So at Facebook, we have a system called Scoob. It's not open source, but there are similar solutions, which basically allows you to do real-time querying on structured data. And this is really, really cool. So for example, this is from one of our from the mesh layer, and basically data set, and basically what it does is it aggregates requests by whether they're coming from a different data center or not, by latency, average latency, and to no one's surprise, going across the world is slower than going to the next room. So there's a paper published in this system by Facebook, so if you're interested in how it works, it's couple of years old, but it's very insightful, so I highly recommend you Google it or something. So final thing on monitoring your services is service frameworks. So what I mean by this is a term I use. What I mean by this is that you want to have a set of primitives that all engineers in your company, all services in your company use. Because what this does after a while is, since everybody's exposing the data in a similar, well-understood way, data hopefully becomes the lingua franca of your engineering organization, and you start talking about P99 latency and requests per second and that kind of useful stuff instead of like user reports. Okay, so chapter 3, the trial. We got all of these metrics. What do we do with them? So I'm going to talk a little bit about alarms. Usually you have also an alarming system that queries your Timeseries DB or your metrics and has some thresholds configured, and if your metrics are above or below or just break the query you set up to, it will page your engineers sometimes in the middle of the night. So first rule of alarms is, Fight Club joke goes here, favor signal over everything else. So if your alarm is not actionable, you probably want to remove it. And you don't want to page people for this stuff. So what does this mean in practice? It means you want to page people for symptoms of your service being down, basically on the what. Most likely, if you're running a backend service, this is like percentage of requests failed or latency or something like that. But you may want to notify on causes that are usually highly correlated to your system not behaving as expected. So for example, running out of disk space in a DB might be something you want to know about, even though it may not mean that your service is going to fail. So it's kind of like an art more than a science. So this is kind of like a corollary, I think it's how you can pronounce it, is basically if your user reports a problem that you didn't know about from your metrics, you have a problem with your service and you have a problem with your alerts. So you have to fix and make sure that you are alerted on it. It's similar like adding a failing test for a bug, but at a much higher level. And then once you're alerted, that's when all the data comes in that we talked about. You want to know, and that's where all the querying infrastructure comes in, that you can go in and dig into what's actually happened with your service. Okay, cool. So now the final part of the talk, some war stories. And how, like, some interesting, examples of how metrics can be useful. So everyone's favorite problem, memory leak. So here's a fun graph from the ODS system I mentioned before, and I think it's fairly easy to spot where the leak was on the right sides. Basically, this plots, a release candidate in blue and its resident set size, and then like a stable version running in production in orange. But like, what's interesting about this slide is that you can use metrics to help you with development. And actually, you probably also want to integrate them with your release process. So basically, in the ideal world, you will have your kind of like candidate run with a part of production traffic, see if it behaves as it should, and then promote it. So metrics are useful for developers as well. Next problem, also famous one, the deadlock. So can anybody guess what's plotted on this chart? It's number of busy threads per worker. And the reason there's a sawtooth pattern is because what happens is, as you run out of threads because you're deadlocking, you also stop responding to health checks, so our deployment system bounces the service, and then it has threads again, so it starts deadlocking and so on and so forth. So the idea is you can use data to validate a hypothesis, dig into it quickly, and make sure whether you are right or wrong. And another thing is that if you have this kind of data, which you don't always really need, you don't care about running threads that much, but sometimes you really care about it. So the idea is for your service framework to have always on data, and then your tooling to be smart enough for you not to get overwhelmed by data, but for data to be there when you need to dig into it. And the final example is the phantom glitch, or when somebody tells you it wasn't working like last hour, but now it seems to be back online. And some of us, we're busy people who go and say like, well, if it's back online, who cares? Like, whatever, it's fine. But if you actually have the data, you can go and look into what happened. So in this case, one of our workers got moved to a region, and the latency was spiked. So this is response latency plotted over time, and it spiked tenfold. So this made us look into why that happened and realized we made some wrong assumptions about our downstream dependent services, and it made us change the way we deploy and make assumptions about the rest of the infrastructure. So if you actually have extensive data, gremlins start to not appear as often. With that, I will leave you with a few sound bites or takeaways for something to think about. So I think monitoring should be like Git. It should be something init when you start the project. It should always be there. It should be very ubiquitous, more than it is now. So if you have the data, your debugging can be fast. And if you have real-time data, then you can debug even faster. You should not wake people up for noise. And monitoring is not only for production. With that, I thank you for your attention. I will not be taking questions here, but if you want to grab me in the hallway, I'd be happy to chat. Thank you so much.